Welcome back to Tales of Chemistry. Today, let us discuss mole concept for Standard 10 icse. What is the meaning of 1 mole? Well, the best way to understand 1 mole is, it is a number. Okay, just like 1 dozen stands for 12 always, right? 1 pair is 2. Similarly, 1 mole of any substance will have 6.023 10 to the power 23 particles present in it. I mean, if you say 1 mole of carbon dioxide, 1 mole of carbon dioxide, this will have 6.023 10 to the power 23 molecules of carbon dioxide. Now, if you say 1 mole of helium, helium exists as atoms, right? Helium is not a molecule. So, 1 mole of helium will be 6.023 10 to the power 23 atoms of helium. Similarly, if you take 1 mole of any ion, say 1 mole of Na plus ion, it will be 6.023 10 to the power 23 ions of Na plus. So that is the meaning of 1 mole. 1 mole represents a particular number. Now, what is the relation between mole and atomic mass? Well, if I say 1 mole of sodium, then this will be equal to 23 grams of sodium. How is 23 related to sodium? 23 is the atomic mass or relative atomic mass of sodium is 23. If I take Mg, then 1 mole of Mg means 24 grams of Mg. All right. So, any particular atom, if taken in 1 mole, that means the weight of it is the atomic mass of that particular element. The number remains the same. 1 mole is always 6.023 10 to the power 23 particle, but the weight will vary. Okay, if you are talking about atoms, then 1 mole's weight will be the atomic mass, atomic weight of the atom. I hope this point is clear. Now, how is this, mole related to molecular mass? Suppose you are taking carbon dioxide and then 1 mole of carbon dioxide will be equal to the relative molecular mass of carbon dioxide. What is the relative molecular mass of carbon dioxide? 12 plus 2 into 16, which is 44 expressed in grams, meaning 44 gram of carbon dioxide is called 1 mole of carbon dioxide. If you take SO2, then 1 mole of SO2 will be the relative molecular mass of SO2, which is atomic mass of sulfur 32 plus 2 into 16. So 32 plus 32, 64 grams. One more example. If you take ammonia, then 1 mole of ammonia is equal to 1 RMM of ammonia. One relative molecular mass of ammonia, which is 14 plus 3 into 1, that is 17 grams. Now, let us see the relation between, or what is molar volume? How is it related to 1 mole? Well, molar volume is the volume occupied by 1 mole of any gas. Okay, if it is a solid or liquid, this concept of molar volume cannot be applied. Volume occupied by 1 mole of any gas at a particular temperature and pressure is called molar volume. It is called molar volume. Volume occupied by 1 mole of any gas at a particular temperature and pressure is called molar volume. At standard temperature and pressure, molar volume is equal to 22.4 liter. We mean to say 1 mole of any gas at STP will occupy 22.4 liters of space. Now, we need to do numericals that connect mole to RMM or RAM and to volume. So let us solve some of these questions. Calculate the number of moles present in 7 grams of nitrogen. So once we read the question, find out what is the data given. It is given that you are taking 7 grams of nitrogen and you need to relate it to the moles. So this is a relation that connects RMM. Because it is a nitrogen molecule, I've written RMM. If it was some metal atom, I would have written here RAM. So RMM connecting to moles, that is the relation. What is the relative molecular mass of nitrogen? Okay, nitrogen's relative molecular mass is 28. So 28 grams of nitrogen is called 1 mole of nitrogen. Therefore, 7 grams of nitrogen will be called X moles of nitrogen. So how do we solve for X now? X is equal to 7 into 1 by 28. 7 into 1 by 28, which is equal to 1 by 4, 0.25 moles. That is the answer. Look at the next one. Calculate the mass of 50 cc of carbon monoxide at STP. So as you read 50 cc and mass of carbon monoxide, what is the relation? You are comparing the mass RMM. CO is a molecule, right? So RMM is connected to its volume or molar volume. They have mentioned STP. So molar volume is 22.4 liter, which is equal to 22.4 into 1000 cc, because the other unit is in cc. What is RMM of carbon monoxide? 12 plus 16, 28 grams. 28 gram is 22.4 into 1000 cc. Therefore, X gram will be 50 cc. Now solve for X by unitary method. X is equal to 28 into 50 divided by 22.4 into 1000. Solve it, and on solving the answer is 0.0625 gram. I hope this question is clear. Let's move on to the next one. Calculate the volume at STP occupied by 6.023 into 10 to the power 22 molecules of a gas. So here it is a relation which connects volume to the number of molecules. So STP is mentioned. STP volume of any gas, irrespective of the gas. They have not mentioned which gas it is, but that doesn't matter to us. Whichever gas it is, at STP, 1 mole of it will have 22.4 liter. 22.4 liter of this gas X will have 6.023 10 to the power 23 molecules. Now the question is, calculate the volume. So I will write X here, X liter, by this volume is occupied by 6.023 into 10 to the power 22 molecules. Now solve for X by unitary method. X is equal to 22.4 into 6.023 10 to the power 22, this and this multiplied together, divided by 6.023 10 to the power 23. On solving, this is a simple calculation. 2.24 liter will be the answer. Okay. Moving on to the next one. Calculate number of molecules in 1 kilogram of NaCl. So again, this is a relation between mass. The moment you see mass, write RMM. RMM is compared with the number of molecules. What is the RMM of NaCl? 23 plus 35.5. So we need to now add it. 23 and 35 will be 35.5 will be 58.5 grams. So 58.5 grams of NaCl will have 6.023 10 to the power 23 particles, molecules as per the question. Therefore, 1 kilogram, right? So in grams, 1000 gram will have X molecules or particles. Now solve for X. Now I am bringing, every relation in such a way that you can solve it by unitary method. So here X is equal to 1000 into 6.023 into 10 to the power 23 divided by the molecular mass 58.5. So the answer here is 17.1 into 6.023 into 10 to the power 23 particles, which can also be written as 17.1 Avogadro number of particles. So I'm introducing one point here. This 6.023 into 10 to the power 23, that number is called 1 Avogadro's number. Okay, Avogadro is written like this, Avogadro's number. Okay, fine. So 6.023 into 10 to the power 23 is called 1 Avogadro's number. Let us move on with question number 5. Calculate the number of moles, number of molecules. So 2 things are to be calculated. Oh no, 3 are there. What is the volume occupied by the gas? So 3 answers are expected here. One by one, let us solve. First one is to calculate the number of moles. Okay, so number of moles present in what? 1.4 gram of C2H4. First step is to calculate RMM. RMM of C2H4 is 2 into 12 plus 1 into 4. That is 24 plus 4, that is 28 gram. Now, what is the relation? Mole with the mass. So, the first relation is connecting mole to mass. Mass is to be written in RMM. So, 1 mole is 1 RMM. Okay, so 1 mole is 28 gram. Therefore, X moles will be present in 1.4 gram. How do we solve for X? So this is the relation, right? So X here will be 1.4 by 28. Okay, so that you should solve 1.4 divided by 28. 0.05 moles are present. Second question was to calculate the number of molecules. So, 1 mole is equal to 6.023 10 to the power 23 molecules. Therefore, 0.05 mole will be equal to X molecules. X molecules. Now, solve for X. Okay, this I'm not doing. Please solve it yourself. Third part of the question is, so I'll erase this just to create some space. What is the volume occupied by the gas at STP? So how do we calculate the volume occupied by the gas? Again, 1 mole of the gas will occupy 22.4 liter at STP, which is mentioned. 1 mole is this much. Therefore, 0.05 mole will have X liters. So you can calculate X by yourself, right? So by cross multiplication, by unitary method, calculate the value of X. Moving on to the next question. One equation is given here, which is the equation for burning of octane. Octane is a hydrocarbon with formula C8H18. It is burnt in oxygen to give you carbon dioxide and water. Question is, how many moles of carbon dioxide are produced when 1 mole of octane burns? So to solve this, you just need to look at the balanced equation. As per the balanced equation, 2 moles of octane requires 16 moles of carbon dioxide. So 1 mole of octane will require 8 moles of carbon dioxide. So the first answer is done without much of a calculation, just from the balanced equation, the number that you are using to balance octane and carbon dioxide, just that is considered. What volume at STP is occupied by the number of moles determined in 1? Okay, so 8 moles are calculated, correct? We read the question again. At STP, calculate the volume at STP by 8 moles of carbon dioxide. 8 moles of carbon dioxide. Now, 1 mole of carbon dioxide will require 22.4 liters. Therefore, 8 moles will require 8 into 22.4 liter. You can solve this also by unitary method. 8 into 22.4. Okay, answer is 179.2 liters. Next, what is the mass of carbon dioxide which is produced by burning 2 moles of octane? So again, I will take the relation. 2 moles of octane gives us 16 moles of carbon dioxide. Okay, so what is the question? What's the mass of carbon dioxide? So I just need to find here mass of 16 moles. Okay, mass of 16 moles of carbon dioxide. Why is it so? The question says you are burning 2 moles of octane. When you burn 2 moles of octane, your result is 16 moles of carbon dioxide. You know, 1 mole of carbon dioxide weighs 1 RMM of carbon dioxide, which on calculation is 44 grams. Therefore, 16 moles will be 16 into 44. 16 into 44 is 704 grams. Okay, moving on. Calculate the volume occupied by 80 grams of carbon dioxide. Carbon dioxide's RMM is 12 plus 32, which is 44. Moving on, calculate the volume occupied. So the relation here is volume connecting RMM, volume at STP 22.4 liter for 1 RMM, that is 44 grams. Then X liter will be the volume for 80 grams. Cross multiply. So X is equal to 22.4 into 80 divided by 44. Let me calculate this. 22.4 into 80 divided by 44 is 40.7272. It's a recurring decimal. You can round it off. 72 or 73 can be written. Yeah, 40.73 liter is your final answer. Volume of 80 grams of carbon dioxide is 40.73 liters. Calculate the number of molecules. So the relation here is connecting molecules with the RMM. Okay, RMM of carbon dioxide, I know 44 gram. 44 gram is 6.023, 10 to the power 23. Okay, now calculate the number of molecules. X molecules are present in 4.4 gram. So, X will be actually without any calculation, you can write it. This is 44, this is 4.4. So the answer has to be 6.023 10 to the power 22. So if you multiply, then it is 6.023 10 to the power 23 into 4.4 divided by 44, which is 6.023 10 to the power 22 molecules are present. The ninth one, the next question. Number of moles in 11 grams of nitrogen. Calculate the number of moles. So this is a relation that is connecting moles with the mass. So for mass, I will write RMM. What is the number of mole? 1 mole of nitrogen will be 28 grams of nitrogen. Therefore, X mole will be equal to 11 grams of nitrogen. Now, calculate X by cross multiplication. That is 1 into 11 by 28. 11 by 28 is equal to 0.3928. So I'm rounding it off. 0.39 moles will be the answer. Number of moles is 0.39. Okay. Moving on. The next question is, state the volume occupied by 40 grams of methane. Methane's vapor density is given. So, molecular mass of methane is twice its vapor density. So, 16. Here, the relation is connecting volume with the mass. So, mass, I'm writing RMM. 22.4 liter, that is volume at STP. This will be 16 grams, and therefore X liter will have 40 grams. Oh, sorry. Yes, 40 grams. So X is calculated as 22.4 into 40 divided by 16. So that is equal to 22.4 into 40 divided by 16 is 56 liters. Okay. So I hope idea of mole concept is clear now. Thank you for watching and stay tuned for more videos.